The recording now. Okay. So again, everyone, good evening. So tonight, our lecture would be on the Bus Admittance Matrix. Okay, so I shared with you a couple of lecture notes. Okay, I hope that you're able to go through that lecture notes. Actually, this is just a review of the construction of the Bus Admittance Matrix. Okay, so I'm sure that everyone is already familiar with the Bus Admittance Matrix. We have to derive that matrix because it will be needed in our load flow computations. Okay. So before I proceed, may I confirm that what you are seeing right now is the first, the page one of the lecture notes, the first one. Tama ba, guys?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Thank you, folks. Okay, so I will now proceed. Okay, so again, the lecture is about the construction of the bus admittance matrix. Okay, so the bus admittance matrix, it is a matrix that contains a lot of information. Okay, so it tells us how the network is interconnected, meaning in the power systems we have several buses, and it tells us which bus is connected to which bus. Okay, so it tells a lot about the topology of the network. Okay, so it's similar to the incidence matrices that we talked about around 2 weeks ago. Okay, now as an added information on the connectivity of the network, also embedded in the matrix are the admittances, the values of the admittances of those branches. So aside from telling us the connectivity, how things are interconnected, it also tells us the impedance or the admittance of the connection. Okay, so I'm sure that in your undergraduate years you were able to encounter the bus admittance matrix, and also you were taught of the most basic procedure, which is based on the nodal analysis. Essentially, we're going to write the nodal equations. Okay, these are KCL equations, and then from the KCL equations, we will derive the equations that relate the currents, okay, the current sources in the network to the node voltages. Okay, so before I proceed, let's just do with some definition of terms. Okay, so the bus admittance matrix, it relates, okay, it relates the current sources in the network to the nodal voltages. So when we say nodal voltages, it's the voltage at each bus with respect to a reference bus. Okay, so if your circuit has a voltage source, then you have to convert it to a current source using, say, uh, using source transformation. Okay, so so moving on, you have already. This is how the equation looks like. Looks like, So this is the node voltage. Okay, so our circuit here has 5 nodes. We have chosen one node as the reference. So V1 is the voltage from that node with respect to this one. V2 is the voltage here with respect to the reference node. V3 naman from here to there, and then V4 from here to there. Okay. And then we have here the currents. Okay, so these are the currents in the current sources. Okay, I1, I2, I3, and I4. Okay, so we do I1. It is the current being injected at bus 1, but we don't have a current source here. Okay, I2 is the current being injected to bus 2, but we also don't have a current source there. Okay, hence we have I3 and I4. So I3 is the current injection at bus 3. And I4 is the current injection at bus 4. So eventually, when you write this equation, you will see that this and this are equal to 0. Okay. Again, take note that the diagonal elements, they are the self admittances, and then the off diagonal are the mutual admittances, and then we have a sort of a mechanical way of constructing this bus admittance matrix. Essentially, the diagonal elements, you just add all the admittances connected to the bus, okay? To the bus corresponding to the row or column number, okay? So for example, Y11 here, it is equal to the sum of all admittances connected at bus 1, okay? So you go back to the original circuit, you add all the admittances connected to bus 1, those are YC, YD, and YF. That would be the element Y11, as you will see here, okay? And then you do the same thing on the other diagonal elements, okay? Now for the off-diagonal elements, the values here is just equal to the negative of the net admittance connected between nodes I and J, okay? So for example, Y12 here, that's just equal to the negative of the admittance between bus 1 and bus 2. So going back, or looking at this example at the bottom, Y12 is equal to negative YD, and that is the negative of this, nasan si YD, this one, this admittance here, which is the admittance between bus 1, and bus 2, okay? So this is how we usually construct the bus admittance matrix, okay? We write the nodal equations, and then we arrange the equations until we extract the coefficients, and then we assign those coefficients in the matrix, okay, in their corresponding places in the matrix, okay? Now, this method is relatively easy to do, if you have a small circuit. However, if you have a big circuit, say you have a big power system with 500 nodes, okay, or 500 buses or 1,000 buses, then it's impractical to write all of these equations, okay? Thankfully, these rules here are simple enough, okay? We just have to look at each bus, go through each bus one at a time, look at the admittances connected to each bus. Then from there we could write, or we could compute for the diagonal elements, and then look at the admittance of the bus connecting one bus to the other, and that's what we do with the off diagonals. Okay, now since the off diagonal element is just the negative of the net admittance, we will see here that Y12 is equal to Y21, Y13 is equal to Y31, meaning the bus admittance matrix is symmetric, okay? So when we say symmetric, if you get the transpose, you'll get the same thing, okay? Now, moving on from this expression here, okay? Let's pay particular attention to one of the branches, okay? Let's say branch YC, okay? And branch YC, it is the branch connecting bus 1 to bus 3 here, okay? And we can see in this expression that YC occurs exactly 4 times, okay? Exactly 4 times. Saan siya nag-occur? So we see that YC, rather, we should be looking here. YC, we can see YC here, we can see YC there, here, and here. There's no other space or location where you can find YC. In fact, you can only find the admittance YC in the rows and columns corresponding to buses 1 and 2. 1 and 3 rather. So essentially, nandun sila sa row 1, row 3, column 1, and column 3. Okay? And we can rewrite this expression, okay, by extracting the YCs, like so. Okay? So you can see here, we extract the YC at the diagonals, meaning Y11 and Y13, Y33 here. Ito na sila. And then Y13 and then Y31. Okay? So we can decompose, or we have decomposed the Y bus as this matrix plus this matrix. Okay? Now, at this point, I will be introducing to you the building block method in constructing the bus admittance matrix. So when we say building block method, we're just saying that this big matrix here is just equal to the sum of matrices, several matrices that look like that. Okay? Meaning the diagonal elements are positive, the off-diagonal elements are negative. This building block matrix is also symmetric. Okay? So you can do the same, say, for y sub b, okay? You could extract another matrix containing only y sub b. And you will see that that matrix will only have 4 elements. You have 2 at the diagonals, you have 2 at the off diagonals, and that matrix will also be symmetric. Okay? Now, take note that y sub b, going back to the circuit here, it is connecting, or yeah, it's connecting bus 2 to bus 3. So we expect a building block matrix that looks like that, but with elements only at rows 2 and 3 and columns 2 and 3. Nasundan ba, guys? So YB is here, YB is there, you have negative YB there and negative YB there. Okay? So essentially, to build the entire bus, bus admittance matrix, we just have to construct this matrix, each matrix corresponding to a particular branch, and then we just add them all up. Okay? I think the best way to do that is through an example, which is right here at the bottom. So malaki na yung itatalon ko, no? By the way, but before I proceed to that example, I have to mention to you this convention. Okay, so take note that we are looking at this particular matrix here. All elements are 0 except for those 4, so we don't have to write all of those zeros. Ano? It's quite tedious. So here we just represent each 0 by a dot. In fact, we don't have to write the entire matrix, kasi if that's a 500 by 500 matrix, you only have 4 non-zero elements. Okay. In fact, we just have to write it this way in a more compact form, okay, wherein we have this 2 by 2 matrix wherein the diagonal elements are 1. So 1, 1, and then the off diagonals are -1 and -1, okay? And then outside of that, you have the admittance YC, and then we have here a couple of numbers on top, telling us what the row or column numbers are, okay? So here you have column 1 and column 3. Okay, so column 1 here, column 3 there. So similar, so since the matrix is symmetric, then we also have the non-zero values at row 1 and row 3. Okay, so moving on to the example. Okay, so let's say that you have already built the impedance diagram. Okay, so you have the single line diagram, and then take note, guys, that everything will be in per unit. Okay, in fact, you already submitted the homework for that. How do you convert this single line diagram into a reactance diagram, an impedance diagram? Okay, you already know how to do that. All of values here are in per unit. Okay, but we are not going to write the bus admittance matrix for that particular network. We have to convert all voltage sources to current sources. Okay, so from there, so essentially that generator is represented by this series reactance and that voltage source. This generator here is this reactance plus that voltage source, okay? This transformer here is that J.1 reactance, and that transformer there is this J, another J.1 reactance. So we will combine these two impedances, so that will become a J.1.25, and here another J1.25 rather, 1.25, not 1.125, 1.25, okay? And then we will convert this circuit, or this part of the circuit, as a current source in parallel with a reactance, okay? Guys, I'm sure you know how to do that, okay? And then we will convert that reactance into an admittance. So all the values that you're seeing here right now are now converted to admittances, okay? So you see here the J.25 is now a negative J for admittance, okay? Sorry. Now, we see here that, let's count the number of branches. So we have 1, 2, 3, 4, 5, 6, 7. So we have 7 branches. It means that since for each branch we have a building block matrix, then we just have to add 7 matrices, okay? 7 matrices that that look like this, okay? We just have to add 7 of them, okay? In fact, here are the 7 matrices at the bottom, okay? So essentially we go through the network one branch at a time. So let's start at branch A. So this is branch A. Okay. So branch A, the admittance of that is YA. So we have this element here. Okay. So take note when we are writing the building block matrix for an admittance that connects a bus to the reference, it's not a 2x2 matrix. It's just a 1x1 matrix. Okay, and we do not have to indicate their bus 0. So if you look at this, wala tayong bus 0 dito. Okay, so this is a matrix with only one element. Okay, with only one element at row 3, column 3, and the value there is YA. Okay, now this one is the building block matrix for branch B. Where's branch B? Here is branch B. Okay, so branch B is the branch between buses 2 and 3. Hence, we have to put there 3-2 or 2-3. It doesn't really matter, ano? That could be 2-3, that could be 3-2. The point here is that whether that's 2-3 or 3-2, you'll get the same matrix naman. Okay, so you don't have to be worrying about that. Okay, so that's YB. Now for the third branch, we have YC. So YC is this branch here. It is connecting node 1 to node 3. Okay, so we have to label there 3 and 1 pertaining to rows 1, column 1, and then we have here the branch YC. Okay, so for each branch here, we will write the building block matrix, and then we just have to add them. Okay, and eventually we will get this matrix. Okay, any questions, guys? Clear ba? Okay, so for example, let's say let's just get the connection between these building block matrices to this Y bus here. So we see here that we have YC, YD, and YF, and that's those are the elements at row 1, column 1. So looking at the 7 matrices here, which of these has elements at row 1, column 1? So we see here a 1 here. So this is the element at row 1, column 1, and that's YC. And then we have another one here, row 1, column 1, and that's YD. And we have another one here, row 1, column 1, and that's YF. Okay, so the elements here are, or is YC plus YD plus YF. Okay, and then there's only one matrix with an element at row 1, column 2. Ito yon. Okay, so that's row 1, column 2. You have a -1 times YD. And you will not see a row 1, column 2 anywhere else. Okay, so you have to put here, or you will now put here -YD. Okay, any questions? Clear ba, guys? Clear? Okay, so
Yes, sir.
everybody, okay,
Clear po.
okay, everybody knows how to build the Y bus using the building block method. In fact, in your first machine problem, I'm going to ask you to build the Y bus using one of 2 methods, and one of those 2 methods is the building block method. Okay, so at the end of this R, we're going to allocate which among you will do it this way, and then in the next few minutes I'll talk about the other way, which is using the incidence matrices. Okay, so hindi muna natin pipiliin so that you will know how to do both methods, and then at the end of the R, you'll just learn which one you will implement. Okay, so at this point, let us now move on to the other method, and the other method is at the second lecture notes. Okay, so by the way, I indicated at the UVLE that the construction of the bus admittance matrix involving branches with mutual impedance is optional. Okay, so please read them if you have time, but there will be no assessment for that. But before I skip this, I'll just have a few comments on why we are doing this. why are we considering branches with mutual impedances? Okay, so going back to this original network, we see here na all of the branches are independent, meaning the current flowing on one branch is not affecting the other branches. Okay. However, there will be cases wherein you have a power system wherein you have two adjacent transmission lines that are sharing a right of way. Okay, so let's say you have a remote power plant somewhere, and then from that power plant you have two transmission lines coming out of it. However, since it is remote, then those two transmission lines will be sharing a small path, one beside the other. And then after going through that path, pwedeng maghihiwalay na sila. They will diverge from each other. However, at that segment wherein they are aside or beside each other, it is possible that they will affect each other. There will be a mutual impedance between those two transmission lines. Hence, we have this like a transformer effect on those two branches. Okay, we will not go through this. Please, if you have time, you can go through that. Essentially, you're going to derive the bus admittance matrix with branches with mutual impedances. Okay. So at this point, I'm going to move on to the other lecture slide. The other lecture notes, part 2. And that is the construction of the bus admittance matrix using the incidence matrix. Okay. Ito. Okay. So this is the second method that I'll ask you to implement when you create the bus admittance matrix. And that is by using a network incidence matrix. Okay. So I hope you still remember a couple of weeks ago, we had a lecture on incidence matrices. Okay. It is a matrix that that tells us the way how the network is interconnected. Okay. So we have several of those. We have the node to branch incidence matrix. We have the fundamental cut set incidence matrix, and we also have the fundamental loop incidence matrix. So for this particular method in building the Y-bus, we will use the branch to node incidence matrix. So take note, guys, I'm not using the term node to branch, but I'm using a branch to node incidence matrix. Anyway, the main difference between the two is that you just transpose one and then you will get the other. Okay, so if you have the node to branch incidence matrix, you just transpose that, you get the branch to node incidence matrix. Okay, so for this particular network here, what we're going to do is we're going to write this equation. So these are the branch equations. Okay. Anyway, to help us understand that figure, I'll just drag this picture here. It's the same circuit. I'll just keep it there. Okay. I'll just keep it here so you could see the equation and the circuit at the same time. Okay. So take note, guys, that VA up to VG, these are the branch voltages. Okay. So when we say VA here, VA is the voltage from this point to that point. Okay. And VB here, okay, VB here is the voltage from this point to that point. Okay. Take note that for each branch, we assign the direction of the branch currents. So the branch currents are IA, IB, IC, and so on and so forth. Okay. So since IA is going that way, it's going down, the polarity of VA is ito, plus, minus. Okay. So the plus will be at this end, and then the minus is at the direction where the arrow is pointing. Okay. So VB is here, plus is here, minus is there. Okay. And then for VC, we're going to look at branch C. This is branch C. Okay. So VC is plus here, minus here. Okay. Any question, guys? Clear ba yung convention natin? Kung ano yung polarity ng VA up to VG? Okay. And then IA to IG are the branch currents. Okay. So you have here a big matrix, and this big matrix here is what we will call the primitive branch matrix, okay, or the primitive admittance matrix. Okay, so we say primitive because we are referring to the values particular to the branches that are primitive to the branches. Okay, so if we multiply the two matrices here, you will see that VA multiplied by this is equal to IA, or the voltage here, okay, multiplied by that admittance, negative J.8, you will get the current going down. Okay. Similarly, VD, nasaan si VD? VD is here. The polarity of VD is plus here, minus here, okay, because the current ID is going down, okay? So that voltage VD plus minus multiplied by negative J8, that is equal to ID, okay? So voltage multiplied by admittance, you will get the current, okay? So VD times negative J8 is equal to ID, okay? VE times negative J5 is equal to IE, okay? So VE is here, plus, minus. So VE multiplied by negative J5 is equal to IE. Essentially, the primitive admittance matrix is just a diagonal matrix. And the element in the diagonals is just equal to the admittance of the branch corresponding to the row or column number, okay? Now, also take note here that we have a couple of branches that has mutual impedance, okay? So the mutual admittance between the two branches is equal to J 3.75, okay? So it means that this current IB will induce a voltage here because of that mutual impedance or mutual admittance. So there is a sort of a transformer effect, okay? Similarly, this current IC will induce a voltage here, okay? It will induce a voltage there because of this mutual admittance, okay? Or another way of looking at that is this current IB, okay? This current IB is caused by the voltage VB and the voltage VC, okay? So IB has two components. One is due to the voltage VB and the other is due to the voltage VC, okay? So yung voltage dito has a contribution to that current. In fact, if you multiply that voltage by that mutual admittance, the result is a current, okay? A current occurring at this branch, okay? So if we look at the equation, we will now see that IB, this current here going to the right, is equal to VB times negative J6.25, or VB times that admittance plus VC, which is the voltage here, multiplied by this mutual admittance, which is J 3.75. Okay? We will do the same for the other current IC. This current here, IC. So current IC is this current going to the right. That current is equal to VC times negative J 6.25 plus VB times J 3.75. Hence, you have a negative J 6.25 here and a J 3.75 there. Any questions? Clear ba, folks?
Yes, sir.
Okay.
Yes, sir.
By the way, guys, if you have any questions, please don't hesitate to ask. Meron tayong thumbs up na button, or you could raise your hand. Okay, so I'll be frequently monitoring the participants box here beside me. Okay, I have another screen beside me. Okay, so essentially we're just going to write the primitive admittance matrix. This is the primitive admittance matrix here. YPR, so you have a subscript there, PR. VPR is the primitive voltage vector. Okay, so we are referring to the voltage at each branch. And then IPR is the primitive current vector, or the current at each branch. Okay. Now, at this point, we will now construct the branch to node incidence matrix. Okay, so when we say branch to node incidence matrix, it is a tall and slender matrix. Take note, yung lecture natin a couple of weeks ago, we are talking about the node to branch incidence matrix. Okay, meaning we are listing the nodes at the left and then the branches on top. Okay, So yung mga rows natin correspond to the nodes, but the columns correspond to the branch. Here we have a branch to node incidence matrix, meaning the branches are here. So each row corresponds to a branch. So row 1 is for branch A, row 2 is for branch B, row C is for branch C, row 3, and then row 4 is for branch D. Okay? And then column 1 is for node 0, column 2 is for node 1, column 3 is for node 2, etc., etc., etc. Okay? Now the element of the branch to node incidence matrix is either 0, 1, or -1. Okay? So if a branch is not connected to the node, then you get a 0. However, if a branch is connected to the node, okay, or is incident to the node, the corresponding row or column or the corresponding space will either get a +1 or a -1. Okay? So the space will get a +1 if the current is away from the node. Otherwise, you'll get a -1, meaning the current is directed toward the node. Okay, so let's just take one example. For example, branch A. So branch A, this is telling us that IA is going into node 0 and leaving node 3, and this is what you see here. Okay, so IA is entering node 0, it is leaving node 3. And you could check the rest of the rows and confirm the signs that you get for the non-zero elements. So it's either 1 or -1, okay, depending on the direction of the current. Okay, so pareho lang siya dun sa node to branch incidence matrix natin before. Okay, now I hope you also recall that after constructing the node to branch incidence matrix, we remove the row corresponding to the reference node. And we will do the same here, okay? So the first column here corresponds to the reference node, node 0. So we will erase, we will remove that column, okay? Because we want the columns to be linearly independent, okay? So we will remove that column, and from having a 7x5 incidence matrix, it will now be a 7x4 incidence matrix. So we remove the first column, okay? Now, using the incidence matrix, the branch to node incidence matrix, we will now relate the node voltages. So these are the node voltages to the branch voltages. Okay. So, for example, VA, nasan si VA? Ito, plus minus. VA is equal to V3 minus V0, or simply V3. Take note that V0 is also equal to 0. Okay. And then VB, where's VB? VB is here, plus, minus. VB is equal to V3 minus V2. And you will see that on the second row, okay? So you multiply that second row with this, you will get a V3 minus V2, okay? And then for VC naman, you will see that VC is equal to V3 minus V1. Ito naman siya, okay? So VC plus minus is equal to V3 minus V1, and so on and so forth. Okay, so now this equation relates the primitive branch voltages to the node voltages. We have that equation. Okay, guys, any questions? Okay. Okay. Now moving on, for each node, we will write a KCL. Okay. So let's start with node 1, for example. Okay, so the KCL there is IC plus ID plus IF is equal to 0. And you will see that here on the first row. Okay, so you have a negative IC minus ID minus IF is equal to 0. Okay, and then for node 2, you have negative IB plus IB minus IE is equal to 0. Okay, so you will see it here. Okay, so you have a negative IB plus IB minus IE is equal to 0. And then for the third node, this one, okay, So the current going in is I3. The current going in is I3. And the current going in should be equal to the sum of all the currents going out. And that's IA plus IB plus IC. Hence, you have here an IA plus IB plus IC. Okay? Take note, guys, that this matrix here is just the transpose of our incidence matrix. Okay? So you get this, you transpose that. Okay, that's our A matrix. You get the transpose of that, and you will get this matrix here. Okay? So essentially, A transpose times the branch primitive currents is equal to the node injection currents. Okay? So you have an I3 and an I4 because we have current sources here and there, but we don't have current sources connected at node 1 and node 2. Hence, 0 to, 0 din ito. Any questions, guys? Okay, still with me? Okay, so take note that we have that equation and we also have that equation. Okay, and then we will put everything together. Okay, so let us now multiply the branch current equations by the transpose of A. Essentially, we are now looking at at hindi makita, no? Sandali. Let's try to show everything together. Kaya lang, masyadong maliit na yata to, no? Okay. So, huwag na lang. Okay. So, A transpose times IPR, the right side of the equation here is that one. That's I. Okay, that's I. And I, okay, I is equal to, I is equal to, wait lang guys, mukhang ano yata. I'm trying to do it differently. Ganito na lang. Let's start with this equation na lang. Yan, ito na lang. Let's start with this equation. Yan, ito na lang. Okay, I'm trying to do it differently. Okay, so this is our starting equation. Okay, multiply both sides by A transpose. Pre-multiply, meaning the A transpose will be at the left side. Okay, so you put an A transpose here. You also put an A transpose here before the I, and you will get this equation here. Okay, so originally we have this equal to that, and then you have an A transpose on both sides. However, we recognize that A transpose times IPR is equal to the node injection currents. Okay, so we will now replace this right side by I. Okay, now what about the left side? For the left side, we recognize that VPR here, okay, VPR is equal to A times V, okay, from this equation sa taas, okay? So we will just replace that VPR by A times V, like so, okay? So what we have right now is an equation that relates the node voltage to the node injection currents, okay? That's the node voltage relating, that's the node voltage multiplied by that matrix, you will get the node currents, okay? And then going back to the very first slide that we have, nasa first slide ba siya? So, this is the node voltage, and that's the node injection currents. And the coefficient here is the Y bus, okay? So it means that, going back here, this matrix here, A transpose times the primitive admittance matrix times A, that is our Y bus. And that is another way to construct the Y bus, okay? So you construct the branch to node admittance matrix, you call it A, matrix A, and then you construct the primitive, the primitive admittance matrix like this one, okay? And then you just multiply A transpose, I'll go down at the bottom, A transpose times YPR times A is equal to the bus admittance matrix, okay? So in our example here, the same circuit, okay? So we have already constructed the A matrix, okay? This is the this is the A matrix. Okay, that's the A matrix. We have already constructed the primitive admittance matrix. We already have that. And then we just multiply A transpose. Nasa na yun? This one, A transpose multiplied by the primitive admittance matrix. And then we have that. And then post-multiply it by the A. So ito, wala pa yung ano, no? Kulang lang yata sa space. So this is A transpose times YPR. And then post-multiply that by A, you will get the bus admittance matrix. Okay? Any questions, guys? Happy? Clear tayo? Okay. Okay, so if there are no more questions, I'll use the last 15 minutes to talk about the machine problem. Okay, so I'll just pull it out right now. But before that, sandali lang, some important notes. Please read all of this na lang. Ano? How are you, properties of the Y-bus? How are you going to change the Y-bus to reflect system changes? These are already mentioned in the study guide. Okay, that I released for this week. Okay, so eventually magkakaroon tayo ng ano dyan, ng assessment for this. Okay, so please go over that. Okay, now for the machine problem, it's already here at the UVLE. Okay, masyadong malaki yung screen. I hope na hindi pa siya nag-log out. Okay, I'm not yet logged out. Okay, so it's here at week 4, bus admittance matrix. And essentially, I'm going to ask you to build the Y bus for the IEEE 108 bus test network. So this is a picture of the bus of the IEEE 118 bus system. Okay, so it's a big network. It's a transmission network. It has 118 buses, 186 branches, 91 loads, and 54 generators. Okay, so take note, hindi nyo siya makakamaya, no? If you really want to, if you want to double check, then it's up to you, no? For this machine problem, you're going to use Octave to write the code. So you're going to write an Octave script. Okay, that's why we have the Octave exercise on week 1. So I trust that after 3 weeks, you're already familiar on how to use Octave. Okay, so you're going to construct the bus admittance matrix for this network. Okay, oops, I shouldn't have done that. Yeah, okay. This is machine problem 1. Okay. So for machine problem 1, you are to write an Octave script that would build the bus admittance matrix for the IEEE 118 bus system using one of 2 methods. Okay. So the input to your program is the system data, and your script should generate CSV files bearing the Y matrix data. So essentially, you have a script. Okay, a script. So when you say a script, it's a file, okay, with a series of commands, and then you're going to run it at the Octave environment. Okay, so when you submit to me, you're going to submit the script, and you're also going to submit the output. Okay, so the script, it will read a file, and then it will also output a file. Okay, so it will read a file. This is a comma separated variable file. So where is that? Dapat yata. Where is that? It's here, this one. Okay, I'll just open this as a new tab. This file here. Okay, so actually it's an Excel or a CSV file. Okay. Anyway, I'll just sandali, may nakita akong tanong doon sa chat box. I'll go back to that later na lang. Tapusin ko muna itong discussion natin. Baka meron ding typo dun sa ano natin, sa lecture natin. Okay, so I'll go back to the question. Where's the CSV file? Here it is. Where? Saan siya? Hindi siya lumitaw. Ayan. Okay. So this is the CSV file. Okay. So it has 6 columns, and then it has a lot of rows because you have 180 plus branches. Sabi 186 branches. Okay, so you have the 186 branches here. Okay, so this is the first branch, and the first branch is connected between bus 1 and bus 2. Okay, it's a type 0 bus, and that branch has a resistance of 0.0303 per unit and a reactance of 0.0909 per unit, and it has a charging admittance of 0.0254 per unit. Okay. How are you going to, ito series impedance lang naman to, no? So easy to implement. Let's go back here. So this is the R. This is the R. That is the X. And then you have a B. You have a B here. Since we are using a pi equivalent model, you'll just have to split that B into 2. Okay, so you divide that by 2. The one half would be here and the other half would be there. That's how we're going to model each branch. Okay, so I'm giving you that file. It's already here. Okay, it's already here. Okay, you download that, and then your script should read that file. Okay, now don't worry because sa baba meron namang command on how that you will use to read that file. This one I'll go to that later. Okay, and then for each branch type 0 is a transmission line. So if you have a transmission line, you have a resistance, a reactance, and a line charging impedance or admittance. And if you have a type 1 branch, you have a transformer. Hence, you will only get, or you will only see a reactance. Okay, so let's go back to that. So here you have a type 1. You have a type 1 branch. You do not have a resistance, but you have a reactance. You do not have the line charging admittance. Okay, let's go back. Okay, so you will construct the Y matrix using one of 2 methods. The first method is you will construct the branch to node. Dapat branch to node to. It's not a node to branch. Okay, a branch to node incidence matrix. I'll just update this. Okay, it should be a branch to node incidence matrix. Okay, and then you will also construct the primitive admittance matrix. And after constructing the branch to node admittance matrix A and the primitive admittance matrix YB, you will perform this multiplication A transpose YB times A to get the Y bus. Okay, so when you implement, or if you are to implement method 1, I will require from you the A matrix, the incidence matrix here, okay, and 2 more files. Okay, one file is the G matrix and the other one is a B matrix. Okay, unfortunately, if you have complex numbers, there's no way to write it at Excel, ano? Okay, so hindi ka makakapag-type sa Excel ng 1 plus J3, di ba? Hindi niya kilala si J. Okay, so I'll ask you to construct a matrix containing the real values, yun yung G, and then the imaginary values, which is B. Hence, when you have the G matrix and the B matrix, you can recreate the Y matrix, the Bus Admittance Matrix, as Y equal to G plus JV. Okay, guys? Any questions on the first method? Okay. Now, for the second method, you will use the building block method. Okay. So, meaning when you load the file, you're going through it, you will go through that one branch at a time. And then as you go through each branch, okay, you will build the building block matrix. And then you will add it on the Y bus that you already have. So that Y bus will keep on growing. Okay. So when you start with the first branch, it's only a 2 by 2 matrix because it's branch 1 to branch 2. And then when you add the second branch, it will become a 3 by 3 matrix because you already have 3 buses involved. And then when you add the third branch, it will expand to a 5 by 5 matrix because you already have 5. You have 5 buses already. And as you add more branches, the Y bus will just keep on getting larger. Okay? Eventually, you will have a 118 by 118 matrix kasi it's a 118 bus system. Okay? So, napakalaki niya. Okay? Now, so you are to use the building block method. The output is 2 CSV files pa rin. Dalawa lang because we do not have an A matrix. Okay? So the matrix or the output would be the G matrix and the B matrix. Okay? So the rest of the document are just additional instructions on the file naming. Okay? How do you name the file? You put there your student number. Okay? And then you zip everything together with the script. Ito yung script natin. Okay? Take note, guys, that when you submit the script, I'm going to run it. Okay? I'm going to load it in my computer and then I'm going to run it. If it's not running, then I'll just go back to you and I'll tell you, hey, hindi tumatakbo yung script niyo. Okay? And then I should be able, and when I run your script, it should produce the 2 files and it should match the answers, the G and the B matrix files that you have sent to me. Okay, kung hindi nag-match, hindi ko alam kung saan yung kinuha yung G and B matrix niyo, no? Okay? So later on, we will allocate who will do method 1 and who will do method 2. And then, by the way, guys, you are free to talk to each other. You are free to double check your work. Ang hindi lang pwedeng gawin is you copy the codes. Okay? Like one of, you have a classmate, tapos na siya, you borrow the code, and then you replace the name of the variables, and then you put your name, and then you submit it as your own. Okay? So guys, malalaki na tayo, matatanda na tayo. Okay? So I trust that you will uphold your integrity while doing this exercise. Okay? Okay? Now, take note that I am requiring you I am requiring the script to read a file. So here, you have to use this function, a CSV read. So essentially, when you use that, the argument of that function is the file name. Obviously, when you call the function, the .m file should be at the same directory with the CSV file. Okay. So hindi naman pwede na magkaibang directory sila. Okay, should be at the same directory. And once you have executed this line, the data inside or the numbers that you will see here will already be stored in a matrix called data. Okay? And then i-inspect niyo na lang kung ano yung nakita niyo sa loob. Okay? Kayo na bahala mag-manipulate. So I trust that you know how to multiply matrices. I trust how you know how to extract values from matrices. Okay, that should have been done by week 1. Okay, and then on the second page are just additional information on some of the functions that we're going to use. To read the CSV file, you're going to use the CSV read function. And later on, by the end of the script, you have to write a CSV file. So you're going to use the CSV write function. So you specify the file name, that's the file name, and this one here is the matrix or the data, okay? The matrix that you want to write on the CSV file, okay? So if you need more help in using Octave, you just consult this source, okay? Yung octave.sourceforge.io. Okay? Any questions on the machine problem? Okay, because kung wala nang tanong, I will now go to the allocation, meaning who will do method 1 and who will do method 2. Any questions? By the way, when is it due? It's due on the 26th of October. This will be 15% of your grade. Okay, yung mga homeworks natin, the first two homeworks that you submitted, 10 points each, and this one is 15 points. And I'm giving you around 2.5 weeks to work on this. Okay? Yeah, 2.5 weeks. So October 26 is a Monday. Okay? And you are to submit the zip file at the UVLE. Okay? Now, before we allocate who will do method 1 and who will do method 2, I'll go back to the chat box. May tanong si Nemi. JAT po ba yung impedance ng VG? Baka typo lang yan, ano? This is, ito ba yun? Yep. VG. Nasaan si VG? Aha. Ito. Yung impedance ng VG is, admittance na yan eh. Yung impedance niya, wala yata siyang impedance. Sorry guys. Let's go back to the first example. Ito rin yata, I think it's the same network. Okay, are we looking at the same network? Yan, same network ba siya? Yeah, same network siya. However, yung first example natin, wala yung mutual impedance, ano? Okay, the impedance is 1.125, sorry, 1.25. So if you get the inverse of that, if you get the reciprocal of J 1.25, it should be negative J.8. Okay?
It's 7 o'clock.
J.8. Okay? So hindi ko magets kung ano yung tinatanong ni Nemi. Baka may typo. Sandali, tingnan natin ha. Nope, not this one, but the other one. Nemi, hindi ko mahanap kung ano yung tinatanong mo. Okay, baka may... ito. Okay. It's just a typo. Typo lang yan. Okay, don't worry about that. Okay, it's just a typo. Anyway, pag in-add na naman natin yan, you'll get the correct answer. It's been corrected here na naman. Okay, negative J.8 na siya. Okay, no worries. Okay. Okay, the submission is individual, ano? Nakalagay ba rito by dun sa una kong nilagay, it's by pairs, but ito individual na. Okay? Individual na siya. So, it's up to you if you're assigned to method 1, it's up to you if you want to write method 2 and check your answer, or if you want to cross-check it with the answer that your classmate is also getting. Okay? So, individual yung submission natin to answer Jovelon's question. Okay, so how do we allocate who is doing method 1 and method 2? I have to finish na, no? Kasi ang promise ko sa inyo, 1 hour lang. It's 7:01 already. Babalik tayo dun sa ating this one. Babalik tayo dito. Okay? So, ito yung ating class list. You will see there your last name, student number, and then this is a random number. Okay? So guys, ang gagawin ko na lang is I'm going to rank you based on the random number, and everyone that will fall into an odd number, you see here 1 to 31, we'll do method 1. Okay? So odd number would be method 1. And then, yeah, if you go to an even number, you will do method 2. Okay? Clear, guys? Okay? Hindi. Magkakaiba kang method yung mga taga Cebu. Okay? Magkakaiba. Okay. So, I will now rank everyone. Oops, hindi ko isasama yung 1 to 31. And I'm going to sort this by column E, diba? Oy, Zoom, huwag ka na mangharang. Nangaharang pa tong Zoom eh. Oh. Hindi ko makuha tuloy yung window. Ayan. Ibaba natin sa sort. Yan. I'm going to sort by column E and I'm going to do it from largest to smallest. Okay? Boom. Okay? So this will be the order. Okay? Lakihan natin. Okay? So those who are assigned to add numbers, you will be doing method 1. So that's Ramos, Bobila, Navales, Gangoso, Cortez, Velus, Aliganga, Silava, Limos, Zubia, Tolentino, dalawang Tolentino pero may student number naman. Paragoso, Oracoy, Gavin, Rodrigo, and Liadones, you will do method 1. Okay? Method 2 naman are Mario, Balingit, Campos, Mangilog, Montilla, Ronquillo, Manzanilla, Henson, Salvidar, the other Tolentino, Tan, Bueno, Relieve, Baral, and Camanse. Okay? So I'm going to post this at the UVLE para just in case hindi nyo makatch, no? There are 29, there are 28 of you, so it means that 3 of you are out there, weren't able to join us. So I will just post at the UVLE who will do what. Okay? Any questions, guys? Any more questions? Okay. Anyone?